Hello friends, this is my first video of quantitative aptitude and the first topic is logarithm. First, let's go quickly through the properties of logarithm. The first property is log xy to the base a will give you log x to the base a plus log y to the base a. Whenever we have a product, we can write that in the form of addition. Now, similarly, the second property goes when log x by y to the base a. It can be written as log x to the base a minus log y to the base a. Here we can see it's given in the division form, so it can be represented in the difference manner. Now the third one, everything to the same base, we have 1. For example, log x to the base x is 1, log y to the base y is also 1. The fourth one is log 1 to the base a is equal to 0, log 1 to the base a is equal to 0. Now the fifth one, log x to the power p to the base a will be equal to p log x to the base a. In this case, whatever we have as a power, when we add log to it, this p will come to the left hand side and will give you this result. And the last property is log x to the base a is equal to 1 by log a to the base x. This is the base changing formula. If you want to change the base, we can always write this in the denominator form. And the last one is log x to the base a, which can be written as log x to the base b upon log a to the base b, which can also be written as log x by log a. Here b is common, so we can omit the b as the base, and we can simply write it as log x by log a. So now let's go through the questions, but before going through, let me make some points very clear that when the base is not mentioned, it's always taken as base 10, and the logarithm to the base 10 are always known as common logarithm. So this was missed from the last part, so I just need to cover it. Now quickly let's go to the question. Now this is the first question we are going to solve, that is log 27 to the base 3. So before going forward, I'll give you the basic formula for it, that log b to the base a is equal to x. This can be written as a to the power x is equal to b. So using this, we can easily solve all the question. So let's go to the first question. The first one was log 27 to the base 3. Let's consider the answer as x. So solving this formula, using this formula, it will be 3 to the power x will be 27, which is equal to 3 to the power 3. Therefore, x is equal to 3. Now the second part, log 1 by 343 to the base 7. Again, 7 to the base x, considering that this is equal to x, 7 raised to x is equal to 1 by 343. So this 1 by 343 can be written as 1 by 7 raised to 3, which can be further written as 7 raised to minus 3, and on the left hand side we have x is equal to minus 3. So the value of x is equal to minus 3. That is the answer. Now the third subpart, log 0.01 to the base 100 is equal to x. 100 raised to x is equal to 0.01. So this can be written as 1 upon this can be written as 1 upon 100, which can further be written as 100 raised to minus 1. Therefore, x is equal to minus 1. This was the first 3 questions that we solved. So the answer for this question was 3. The answer for the second question was again 3. And the answer for the last question was minus 1. Sorry, for this one is minus 3. So let's go to the second question. The second question is also very simple. It can be also solved in a similar fashion. So I'll just explain here only. 7 raised to x is equal to 1. That is, the x will be 0. So the value for this is 0. According to the property that we said, that anything to the same base, that is log a to the base a, is always 1. And the third will be 100 raised to x is equal to 0.01, which can be written as 1 upon 100, which can be further written as 100 raised to minus 1. So the answer is minus 1. So the next question is log 3 to the base 5 into log 25 to the base 27. So solving the first question, it can be written using the formula that we saw in the first part, that is log x to the base a can be written as log x to the base log a. The x part will go up and the base will always be in the denominator. So using the same formula, we can solve the first part, that is log 3 by log 5 into log 25 upon log 27. This can be further written as log 3 upon log 5 into this 25 can be written as 5 square, and this 27 can be written as 3 to the power 3. So according to the formula, that is x raised to p, and if we have log in front of it, we can easily write this as p log x. So using this, we can write this as 2 log 5 upon 3 log 3. Now we can easily see that this log 3 gets cancelled, this log 5, this log gets cancelled. So the final answer for this is 2 by 3. So solving the second subpart, that is log 27 to the base 9 minus log 9 to the base 27. This can be solved individually and can be subtracted later on. So going for the first part, it can be easily written as 9 to the base 9 to the power x is equal to 27. It can be written as 3 square and 2x, since it's written 3 to the base or 3 to the power 2 and multiply by x, so it is equal to 3 raised to 2x. So using this formula, we can write here 9 raised to x is equal to 3 raised to 2, that is 9, into x. So that will be 3 raised to 2x is equal to 3 raised to 3. So basically 2x, since the base is same, 2x is equal to 3 and x is equal to 3 by 2. So the answer for the first subpart is 3 by 2. Now similarly solving the second subpart, that is 27 to the power x is equal to 9. So 3 raised to 3, that is 27, into x is equal to 9. This can be further written as 3 raised to 2. Therefore, base same, power is equal, 3x is equal to 2, x is equal to 2 by 3. So the first value is 3 by 2, second value is 2 by 3. So going back to the question, solving the first answer was 3 by 2 minus 2 by 3, and the final answer is 2 by 3. So going to the next question. In this question, we need to find the value of x which satisfy the given relation. The relation, that's the equation given here, and we need to find the value of x which will satisfy the whole equation. So looking at this one, we can clearly see it seems a bit odd. So we can change this one in something like this. So the question here arises, why are we going for 10 to the base 10 and not something else? So the reason behind it is the log 10 given in the previous values. So if we had log 1000, something to the base 1000, we would have written here log 1000 to the base 1000. So looking at the right hand side values, I got log 10 to the base 10. So I can do further computation on the same base. Otherwise, I would need to change the bases. So writing 1 as log 10 to the base 10. So the next equation, or the next property that I'm going to use is when we have log a to the base 10 plus log b to the base 10, we can write that as log ab to the base 10, or vice versa, we can write it. So using this property, I'm going to solve the above equation, like log 3 into 4x plus 1 to the base 10, multiplying these two and skipping the base same. And similarly on the right hand side, 10 into x plus 1 and log 10 is taken as common from both using the above formula. Now log 10 and log 10 get cancels, and the equation that remains is 4x plus 1 is equal to x plus 1 into 10. 3 4 is 12x plus 3 is equal to 10x plus 10. This was wrong. So 2x is equal to 7 and x is equal to 7 by 2. This is the final answer. So now going to the next question. We need to simplify this question. It seems a bit long, but we can just write this whole equation in changing the base. We had a formula like log x by a can be written as log 1 by log a to the base x. So using this property, we can rewrite the above equation as log xy to the base xyz. Why I have chosen this property? Because it's very obvious that we have got xyz, and the one thing that we need to consider that we should try to keep the base same always, because when the bases are same, because all the properties that we saw that only applies when we have got the same base. So I'm just trying to keep the base same. Therefore I used the above formula and I wrote the same equation as log. Since it was already given in denominator, I took the reciprocal and the final computed value will be log xy to the base xyz. Now for this it will be log yz to the base xyz. And for the third one, it will be log zx to the base xyz. Since all the bases are same, and as we used this as in the previous question, the final answer will be log xyz. And since all are in plus, we can multiply this xy into yz into zx, which is nothing but log of xyz, and this is xyz whole power 2. And we had a formula that anything which is in the power and we have got log, we can put that to an extreme left of that log, that which will be equal to 2 log of xyz to the base xyz. And we know that anything to the base same as the base will be 2 into 1, which will be 2 will be the answer. So this is the last set of 5 questions that has been given for all of you to solve. Try your level best to solve all of them. If any problem is there, I'll give the solution in the next video. Thank you.